Hello, Matt Davis here, providing some review quiz question help. This one is from Chapter 5. Let's jump in. 87.9% of college students carry a cell phone with them on campus. Suppose 9 college students are randomly selected. Let x equal the number of those selected that were carrying their cell phone with them and calculate mu sub x. And then we're also going to add the next problem from the quiz here too, which is calculate sigma sub x and calculate your answer using 5 significant figures. Those rounding directions apply just to the sigma x. We'll talk about what to do for mu sub x as we go through that one. But the first thing we're going to do is change the sample size right here from 9 to 11. That way we're giving help, but not the answers. All right, so both of these are fairly straightforward. The key is recognizing the situation that we're in. This is a success-failure problem because they're counting the number of successes out of 11 tries. So we're going to say that our n is equal to 11, and p is equal to the probability that a randomly selected student would be carrying their cell phone with them, which is equal to the percentage of the population that has that trait. So we take that 87.9% that they gave us right here, we change that to decimal form. Then we switch over and find q by doing 1 minus p, and for that we get 0.121. So once we have n, p, and q, it should be pretty quick and smooth sailing from there. Mu sub x has the shortcut formula n times p, and in this case that would be 11 times 0.879. We go to the calculator for that. It's a fairly straightforward calculation, and it gives us exactly 9.669. So they didn't actually give us rounding directions for mu sub x, and that's because when you're given a decimal value for p and then you multiply that by n, you don't have to end up rounding it all. So we'll just take that answer, and that's what we'd enter into active learning. All right, so now we'll go to the sigma x part of this question. So for that one, we're going to use a shortcut formula also. That'll be the square root of n times p times q. So that would be the square root of 11 times p, 0.879, and times q, 0.121. So we're just going to go put that into the calculator, and that one is almost certainly going to end up being long and messy, so we'll round it. But let's go see what we get. So switching over to the calculator, we want to do our second square root right away. The calculator does an open parenthesis for us, and we don't want to close that parenthesis until we have all 3 numbers in. So 11, which is n, times p, which is 0.879, times q, which is 0.121. So there's our square root of npq, and open parenthesis from the calculator, we put all 3 numbers and then we closed it. Don't put parentheses around the individual numbers. You don't even have to do that if they're fractions for the square root of npq type question, but you definitely don't want to do it when they're decimals. Just one open and then one closed once you've entered all 3 numbers. And then we get 1.081641808. We want to round that to 5 significant figures, so 1.0816. That 6 would be our 5th significant figure. It's followed by a 4, so we will stick with the 6. So let's go back and write that down. So we get 1.0816. That is our value for sigma x. That has 1, 2, 3, 4, 5 significant figures. So that's what we would enter into active learning. So just looking at some spots where this might go wrong for people, make sure that you convert your p to decimal form. If you try and use the 87.9 and then do 1 minus 87.9, you'll get a negative for a q, which doesn't make sense. So we always got to convert those percentage values to decimal. And then don't close your parentheses until all 3 numbers are entered in for the sigma. And remember to use 5 significant figures for sigma. And no need to round that mu, so just put all of the decimals you get from your calculator from that one. I hope wherever this went wrong for you, you see your mistake and that you have better luck as you go back to the quiz. Just remember these shortcut formulas, mu equals np and sigma equals the square root of npq, only apply to npq questions, which are success-failure ones. And in this case, we're in that situation because we're sampling 11 people, and then we're letting x be the number of them that have a certain trait. And when you're in that situation, that's the NPQ situation. That's where the shortcut formulas apply. Okay, once again, good luck to you as you go back to that quiz.